Hello guys, in this video I would like to explain whether regression fall under machine learning or not. Usually we do regression analysis and some basic courses of statistics, and we don't know whether regression fall under the machine learning or not. So in this video I would like to explain the the concept of regression analysis and what we do in regression analysis in detail, and what are the similarities between regression analysis and machine learning. So based on those similarities we can conclude that whether regression fall under machine learning or not. So this is, I have done a video on this topic, on this on this material, but the title was different. So I was thinking, let's have a video on this title so that it can be easily understandable for the audience that whether regression fall under the machine learning or not. So let's try to explain in detail. Okay, so this is something like regression analysis, and you can see this is the response variable y, and then this is the intercept, and then this is the regression coefficient of this xi, or you can say x1, and this is the value of the predictor, the predictor, so observed value. So this is, you can see something like weights. These are the weights. Beta 1 is the weight for x1, and if you have more variable like x2, x3, then there should be beta 2 and beta 3 respectively for x2 and x3. So those are considered as weight. And you can see, okay, this is something like, predicted. This hat means this is the predicted value, and estimate of the regression slope. So you can see this is a basic concept. And now this is, you can plot this line, this y is equal to beta naught plus beta 1 x1. This is plotted. This blue line is this regression line. This is estimated line. And these are the observations from which these parameters are estimated, beta naught and beta 1, and then the line is plotted, and the observations are also plotted around this line. So you can see that there is differences in the line and in the dot and the observed values like here. So this difference as the error term, or you can say the epsilon in the regression model. Similarly, here it is, the value is much larger as compared to the other values, and some values are just on the line, so there is very small error in some for some observation. So this is some the basic concept of the regression analysis. We estimate the parameter, and this considered as a weight for the corresponding predictor, and this is the error term is the difference between the predicted value. This is the predicted value is here by this line, so this particular value you can say it should be here, and this is the observed value. So the difference between the predicted value and the observed value is the error term, or you can say the residuals. I will have a separate video on the residuals, what is mean by residuals in detail, so that you can understand what is mean by that. Okay, now I would like to explain whether regression fall under machine learning or not. So let's read this text and then talk about this text, what is mean by this text. Linear regression is often considered a machine learning algorithm because it fits the criteria and principles of ML, machine learning, despite its root in statistics. Here are some reasons why linear regression is categorized under machine learning. Okay, so now we have the reasons, and we can compare the reasons with what we do in the machine learning, that so that we can come up with the conclusion about regression, the concept of regression. Prediction and generalization objective. Like other ML algorithms, the primary objective of linear regression is to make predictions. Yeah, this is the basic purpose of regression, is the prediction and the linear regression. But some regression, like logistical regression, we can do classification as well. In terms, it learns from historical data, training data, to predict outcome for new unseen data test data. So yes, the same thing. What we do in machine learning, we do in the regression analysis. We train the model. Train mean we estimate this parameter. In this case, we have two parameter, but we can have more parameter if we have more response or more predictors. So in that case, we estimate the parameters from training data, and then we predict the response variable using the parameter obtained from training data and using the new data for x1 in this case, and maybe x2, x3 if you have more covariates. You predict this response variable based on the parameter obtained from training data and then some new data for the covariates. So that's mean like this statement. Generalization of linear, okay, just let's do like this. Generalization of linear regression model aims to generalize well to the new data, which is a core principle in machine learning. So yes, so what do we do in the machine learning? We do prediction with the new data, and similarly we do in the regression analysis. So this is called sometimes generalization as well, like we do here. There's generalization concept. Learning from data, training process, these things are some in some ways they are repeating, but you can see maybe there are some differences as well, so that you can clear our concept about what is happening behind the regression process. Because normally we run a function and we estimate the parameter. We don't know what is running behind that concept. So this is just like to see the details about this regression model, and just the function in Python, and or learning from the data. Training process. The linear regression involves a training process where the model parameters weights and intercepts. You should know that weights, I already explained, this is the intercepts and this is the weight for this x1. And maybe if you have more covariates, you can have beta 2, b2 and b3 for other covariates. So this is considered as weight in this case. So weights and intercept are adjusted to minimize the error between the predicted values and the actual values in the training data. This is similar to the learning process in other machine learning model. Yes, this is true. We estimate these parameter, technique. I will have a separate video on the OLS estimation, so then I will explain that in detail. But the principle in the regression analysis is that we estimate beta naught and b naught and v1 such that we minimize the residual, the sum of square of the error. So we just sum this error and then square it, and then we minimize it. So in that case, this is the principle in machine learning as well. This means like this: we are minimizing the minimize the error between predicted values and the actual values in training data. In training, we are doing like this. Error minimization. So the same thing, the model learns by minimizing the cost function, usually mean square error. Yes, this is the mean square, sum of square of the error, which is a common approach in machine learning to optimize models. So the same thing we are doing, these two things like this. This is the machine learning, the primary prediction and then minimization of the error. So two things are the same as we do in machine learning and regression analysis. Algorithmic in nature. Linear regression is an algorithmic approach to finding the best fitting line through the data points. This systematic approach to learn from the data and making prediction fit well within the machine learning framework. The same thing as we do in machine learning, also we do in regression analysis. We just try to find the best line, the best fitting line through the data points. Yeah, so minimizing the error term and try to find the best fitting line. So this is the same thing as we do in machine learning. Supervised learning approach. Label data. Linear regression is a supervised learning algorithm, meaning that it's required label data to learn the relationship between input features, independent variables, and output dependent variables. So in this case, you need independent variable and you need a dependent variable. Independent variable are covariates. we represent that by x1, x2, x3, and so on, and the response variable, dependent variable, are represented by y. So this is the same thing as we do in machine learning, the same thing we do in regression analysis. And supervised learning, I will have separate video on supervised learning, unsupervised learning, and reinforced learning, and this type, so that you learn in detail about this concept. But in this case, you need to, you can do prediction and you can do classification. For that, you need different, dependent variable and independent variable. And if you do cluster analysis, that is unsupervised learning. In that case, you don't need response variable. You just need to try to find pattern and some structure in the data. Regression task. At a specifically addressed regression task, predicting continuous outcome, which is a key area of supervised learning in the machine learning. So we do prediction and regression. We do prediction in the regression task, and this is specifically regression task. Machine learning can be used for regression task, for classification, and for time series analysis. So regression or prediction or regression task is of a prominent aspect of machine learning. So that's of course matching with the machine learning. Regression is matching with the machine learning. Application ML pipelines. Linear regression can be part of more complex ML pipelines involving feature selection, processing, and other ML algorithms. So yeah, this can be a part of other, advanced and complex machine learning pipelines, and of course in the future. Model evaluation. Techniques such as cross-validation, regularization, AG Lazo, Ridge, and for performance metrics, AG R squared, MSE, mean square, used in linear regression, also the fundamental in other ML models. So this type of techniques which we use for cross-validation, or we use some performance metrics for to check the performance of the model, used in linear regression, is also fundamental in the machine learning. Yes, of course, this is also the matching. Scalability and automation. Yeah, sometimes you have more data, you have huge data sets, so you can use the scalability, the scalability concept to make it easy for for estimating the model parameter, and you can do the scalable concept in other cases as well. Not only have huge data in this data require a lot of time for computation and estimation of parameter. So this is also this is also a common requirement in machine learning as well as in the regression. Integration of ML framework. Integration with the ML framework. Linear regression is an integrated into popular ML libraries like Scikit, Learn, TensorFlow, emphasizing their role within the broader ML ecosystem. So yeah, of course, this is the same thing you can do. Between the same libraries in which you are using machine learning. So this is some type, some you can say like, in the same package or libraries. Conclusion. This is the general conclusion about linear regression fits within the domain of the machine learning because it's share the fundamental principle and goals of ML algorithm. Yeah, we have discussed this already. What they share, machine learning and regression share some point, like learning from the data, making predictions, and generalizing to new data. While it has its root in statistics, its application and methodology align closely with the machine learning practice. So this is something which machine learning required and also regression required. These are some of the requirement. And so what we conclude, you conclude that there's important point aspect which are shared by two, the regression and the machine learning. And therefore we can say, broadly we can speak that regression fall under machine learning, and you can say this is a type of machine learning. So if someone asks you and you know about this concept, you can just you can convince him or her that yes, this is a machine learning. In fact, we do all these processes in estimating regression model, but we don't see that actually. We just run the function and say, so all these processes are behind this regression estimation. So the conclusion is that yes, regression is a machine learning technique, you can say. Yes. So thank you very much for today. And this is enough for today. And see you in the next video. Ciao.